Okay, so hello Jam aspirants. I hope all of you are doing perfectly well. और आज की क्लास में आप लोग देख ही पा रहे होंगे बहुत सारे क्वेश्चंस लेके मैं आया हूँ फ्रॉम रोटेशनल डायनेमिक्स और ये सारे क्वेश्चंस एक एक करके हम लोग सॉल्व करेंगे. जो भी बच्चे ज्वाइन हो रहे हो क्लास में ज़रा एक बार बता दो कि इफ़ यू ऑल कैन see the screen properly or not, if you can hear my voice properly or not. देखो सबसे पहला क्वेश्चन यहाँ पे आप लोगों के सामने स्क्रीन पे है जिसमें कहा गया है कि फिगर 10.E4 shows two blocks of masses small m and capital M connected by a string passing over a pulley. इस पुली के ऊपर से पास कर रहा है. The horizontal table over which the mass m slides is smooth. ये टेबल स्मूथ है. The pulley has a radius r, moment of inertia I about its axis. It can freely rotate about the axis. Find the acceleration of the mass capital M assuming the string does not slip over this pulley. The string is not slipping over the pulley, that means the pulley is rotating. The pulley is in rotational motion. And of course, we know all this, so we can just start solving this question. So, if you just want me to draw the free body diagram, for this problem, I can do it for you. So just hang on for a moment and I will add the image of it. I'll add the image of it, just hang on for a moment. Okay, so I think more or less all of you can see that an image has been added. Yes, this is the image. Now we will try to solve this question. Basically, there are kind of forces that we can see here. First of all, just because the pulley is not massless, so of course our tension is working on this side of the pulley. Say this is actually your T1, and of course the same tension is also acting on this side, that is T2. This is T1. So this is acting on this mass, this one is acting on the pulley. Here also on the mass capital M, tension is acting on the upward direction, that is your T2. And here on this pulley, tension is acting on the downward direction, that's your T2. Now, on both sides of the pulleys, the tensions are not same because the pulley has a mass and the pulley is rotating. So, of course, if the tensions were same, the pulley could not rotate. The pulley is rotating, that's why the tension must have been different on both the sides. Okay. Here we know that the mass capital Mg is acting on the downward direction. Capital Mg is acting on the downward direction. Capital Mg is acting on the downward direction, and of course over here there is a small mg acting, but that is getting neutralized by normal reaction. Here you can say that small mg is acting, but of course that is being neutralized by the normal reaction by the table, so we are not considering this thing. Okay, so now if I had to write down the equation of motion, how would I do that? If I had to write down the equation of motion, how would I do that? So first of all, just because they're connected, the string is inextensible. Just because the string is not inextensible, so definitely both of them has the same acceleration. Okay, both of them has the same acceleration. If both of them has the same acceleration, then I think it's very easy to find out what will happen. If both of them has the same acceleration, then for this I can write down the equation of motion. For this I can write down the equation of motion. Right? So one thing is capital Mg minus the tension acting in the upward direction T2 is giving the acceleration of capital M. So capital M into A. In a similar manner, I can write for small m. So only one external force acting on it because the mg and normal direction cancelling each other. This table is smooth. So no frictional force, only T1 is acting on this mass. So small T1 is actually equals to your small m into the same acceleration. Both the masses have the same acceleration. And after that, there is a torque acting on that pulley. What is the torque that is acting on that pulley? Can you just say what's the torque acting on that pulley? What is the torque that's acting on that pulley? Can you tell? So of course we can say, so for this case, this is the action of force, so this is your R cross F. R cross F is the downward torque. R cross F, that's the downward torque, and for this case, this is your R cross F. In this case, this is the direction of R, this is the direction of F, so R cross F is basically your the torque acting over here, and this is R cross F, the torque acting over here is this. So you can just write it down. But finally, which one? The pulley is rotating along which direction? If it's coming in the downward direction, capital M is greater than small m. So of course, you can say T2 is greater than T1. I can say this. T2 is greater than T1. T2 is greater than T1. I can say if T2 is greater than T1, so definitely you can say that. Of course, the net torque should be into the plane of the page. So if you ask me to write down the coordinate axis, so suppose this is your x, this is your y, and suppose the z is along the upward direction. The z is along the upward direction. The z is along the upward direction. So for this, you can just write down. I can tell you that for this R cross F, so R I cap cross T2, which direction? In the downward direction, so minus J cap. T2 minus J cap, this is one torque, plus there is another torque, that is this torque, that is R upward direction, this, so it's J cap cross this torque. T1 is acting, so T1 is acting along minus X cap, so T1 minus X cap minus I cap. This is another torque, so both this torque should give me I into angular acceleration alpha, moment of inertia into angular acceleration alpha. Now just have a look. What I'm getting. So I cross J is equals to K, so I'm getting minus K. So RT2 minus K cap, and from here I'm getting J cross I. J cross I is equals to minus K, but there is a minus n, so plus K. So RT1 plus RT1 K cap. That's providing me I into alpha, the moment of inertia of this mass into alpha. Now you tell me one thing. So what I'm gonna get? So just because we know T2 is greater in magnitude than T1, because this one is greater, the larger height, the string is coming in the downward direction. So T2 is greater than T1. So I can write R into, or T2 minus T1 will be positive. T2 minus T1 will be positive into R into minus K cap. Minus K cap means the net torque is acting into the plane of the page. That means the pulley should rotate like this way. Okay, so that means should be equals to I. The moment of inertia they did not mention, did they? It has a moment of inertia I. Okay, so fine. I into alpha can be written as I into alpha. That's all I can say. If I'm only concerned with the magnitude, then I must tell that this can be written as like alpha can be taken as like A is equals to R into alpha, and so alpha is equals to A divided by R. Alpha equals to A divided by R. Then put T1 and T2 from here, you will get the answer. Okay. So if I'm only concerned with the magnitude, so for pure ruling, for ruling without sleeping, for ruling without sleeping, I know alpha should be equals to A should be equals to alpha into R. Alpha into R. So you can find out A from here, and you know alpha. So just write it down. That T2 minus T1. T2 is equals to what? T2 is equals to capital M into G minus A, or capital M G minus capital M A. This is my T2, negative of T1. T1 is small m a into R. I'm just talking about the magnitude, so direction I'm not considering now. I into alpha. I is I. Alpha can be written as A divided by R. A divided by R. And from this expression, you can very well write down that acceleration A is actually equal to, you bring all these terms over here, you can just put R square, then IA, you know, IA plus MA R square plus small ma R square is actually equals to capital MG R square. So you just cancel R square, R square, R square. Here is an R square in the denominator. You take A common. So capital MG divided by small m plus capital M plus I by R square. So A is capital MG divided by small m plus capital M plus capital M plus I divided by R square. Just wait for a moment, I will just turn off my video so you can all see the calculation. Okay, you all can see the calculation, right? Just have a look if you all can see the calculation or not. This is an easy question. This question is not tough at all. Well, of course, the resultant torque is in the inward into the plane so that it will rotate along this direction. Of course, the resultant torque will be into the plane so that it rotates in this direction. It's rotating along this direction, so of course this direction, so torque should be into the plane. And just we know that T2 is greater in magnitude. We should know T2 is greater than T1. We know this thing. T2 is greater than T1 just because this is the larger mass. Capital M is greater than small m. Capital M is greater than small m, so of course T2 should be greater than T1. If T2 is greater than T1, so T2 minus T1 is positive, so this torque, the resulting torque is positive and it's acting along the negative t cap. So negative z-axis is inward, negative z-axis is inward, that means the torque is acting in the downward direction, into the plane of the pitch, so of course the rotation will happen clockwise. Okay, so that's why the pulley will rotate this direction, this will come down and this will come on this direction. Good, everything is done. Everything is happening according to our plan. Now can we do the next question? Can we go to the next question? We have the next question over here, that a string is wrapped on a wheel of moment of inertia 0.2 kg per meter square and radius 10 centimeter and goes through a light pulley to support a block of mass 2 kg as shown in the figure. The acceleration of the block. Okay, fine. So there is a string wrapped on the pulley and it's coming down. So this wheel has a moment of inertia, goes through a light pulley. This pulley is light, this pulley is massless. So the string will sleep over this pulley, but this pulley will rotate. This pulley will not rotate, this pulley will rotate. You just have to find out the acceleration and all. Can you do this? Tell me. So let's just solve this question. This one is easy because you see, I just have to take the just let me take the figure and I'll show you the free body diagram and we will do it. Okay, I think you all can see this figure. This one is not rotating, this one is rotating, right? This one is not rotating, so of course the tension on both the sides will have to be same. So the tension on the block is T, tension on that pulley should be T as well. This pulley is not rotating, so on both sides of the pulley the tension should be same. This is T, this is also T. Over the same rope tension should be same, it should be same. But on this pulley, just because it's not rotating, so this side tension and this side tension should be same. And of course it has a mass of 2 kg, so definitely you can just think that mg should act in the downward direction. Mg should act in the downward direction. So I can write down that for this case mg minus tension is equals to mass into acceleration. For this one it's creating a torque because of which it's rotating, right? So tension T, which is acting along this direction, the R is along this direction, so R cross T this, so it's rotating along this direction. The tension is, of course it's rotating along this direction. The rotation is happening along this direction. The rotation is happening along this direction. So what do you expect? The tension should be perpendicular to the plane of the page and towards you. Perpendicular to the plane of the page and towards you. The tension should be perpendicular to the plane of the page and towards you. So you see, if this is the radial direction R, this is your tension T. So R cross T is actually perpendicular to the plane of the page and towards you. So definitely the direction of tension is fine. We can solve this question. So it will be T cross R. If I just I'm only interested in the magnitudes of T into R, and angle between them is of course sine theta is sine 90. So TR should be equals to cross sine 90 should be equals to what? Your inertia, moment of inertia into acceleration. So moment of inertia of this I'm taking as I into angular acceleration as alpha. These are the two equations. So of course T can be written as I into alpha divided by R. Now we all know that angular acceleration for rolling without sleeping, so of course we all know that alpha R, acceleration A is equals to alpha into R. Now acceleration A equals to alpha R, so alpha equals to A by R, so this can be written as I A by R square. I A divided by R square. It's a good thing. I A by R square, right? Yes. So this is your I A by R square. Tell me, just T is your I A by R square, put it here. You just need to find out the acceleration, right? Therefore, just put this thing over here. This equation will now become mg minus T equals to I A by R square. So I A divided by R square is equal to mass into acceleration. What are you getting? Bring it on this side. So acceleration A is equals to mg divided by m plus I by R square. I by R square. M plus I divided by R square. mg divided by m plus I by R square. mg divided by m plus I by R square. M plus I by R square. So I think it's a very easy question now, because you know the mass of this, you know G 9.8. Moment of inertia you don't know for this pulley. Do you know the mass of this pulley? Yeah, the moment of inertia, okay. The wheel of moment of inertia 0.2 kg meter square. So it's 0.2. It's been said that it has a moment of inertia 0.2 and it has a radius of 10 centimeter. So I equal to 0.2 Acha, R is given in centimeter. Please bring it in meter, okay? You can't put centimeter thing. Everything is kg meter square. It's kg meter square. So this thing you have to also bring it in meter. It's 10 centimeter. That is 0.1 meter. 0.1 meter. So of course, if you just do the calculation now, you will get the answer. 0.1 square, whatever you are getting, 0.2 divided by that. Whatever you are getting, plus you are getting 20 here. 20 plus the mass, that is 2. Whatever you are getting, take the inverse. Whatever you are getting multiplied by 2 into 9.8. 0.89. 0.89. And m has been mentioned as 2 kg. Just put everything over here, you're going to get 0.89 meter per second square. Acceleration is 0.89 meter per second square. Acceleration is 0.89 meter per second square. Meter per second square. That's the acceleration. Can we do our next question? This is our next question. What does the question says? Now suppose the small pulley, now the question is exactly the same. It's exactly the same as the previous problem, but here they have made a very little change. What is that? In the initial case, this pulley was massless. Now they have given a mass to this pulley. Now suppose the smaller pulley of the previous problem has a radius this and moment of inertia this. Now this pulley has a mass, so it has a moment of inertia. Find the tension in the part of the string joining the pulleys. Find the tension in the part of the string joining the pulleys. Find the tension in the part of the string joining the pulleys. Okay, I don't have any issue to just understand how the things are happening here. I can just understand it very nicely. Just have a look. Well, I know now this has a mass, right? If this has a mass, so of course the tensions will be different. Here the tension will be T1. Here it's T1, T1, T1. This T1 is over the block, this T1 is happening on this small pulley. Here the tension has to be T2. Sir, why T2? Now this one has a mass, so this one is rotating. So tension on both the sides cannot be same. T2, 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 T2. Now you just say this one has the weight acting in the downward direction. What is it? mg. The weight is mg, right? Now let me tell you. Sir, mg minus t1. I can write mg minus t1 is equals to m into a. mg minus t1 is equals to mass into acceleration. Now this pulley has some equation which is if this is the center of this pulley, so this is r cross t in the upward direction, the downward direction. So for this pulley, if you ask me to write it down, I know that this case the r should be along this direction and this is your t1, so r cross t is upward direction, so positive k cap. So t1 r k cap, and here r is along this direction, so r cross f it's in the downward, so minus k cap. So t2r minus k cap should be equals to I, moment of inertia, I into alpha. It should be equals to I into alpha, or rather moment of inertia of this pulley, right? I1 into alpha. I1 into alpha, that's all I can say. You can write it down. So of course both of these pulleys will have different angular accelerations. What do you say? Do you agree that both of these pulleys will have different angular accelerations? So let's write it as alpha 1. The angular acceleration for this pulley. We will write it as alpha 2. Fine. So what I'm getting finally from here. Acha, what is greater, T2 or T1? So this is going in the downward direction. So of course T1 is greater than T2. So let me write it down, T1 minus T2. T1 minus T2 is a positive thing. R into K cap. Okay, tell me which direction the torque is acting. K cap is in out of the plane of the page. K cap is out of the plane of the page, so it should rotate like this. Yes, it is rotating like this. It's rotating like this. This one is also rotating like this. So no doubt, sir, everything is fine. It's rotating like this one is rotating like this. Good, that is actually equals to I1 into alpha 1. So I1, alpha 1 can be written as A divided by R1 square. So let's, the radius of this is R1. So this is R1, I divided by A divided by R1 square. Now what can you say about the second case? What can you say about this one? So that's another one. So here you have only one tension T2. So R is along this direction, R cross F. So T2, R2, it's K cap. That is actually acting along I2 alpha 2. So if I just ignore the vector sign, so T2 R2 should be if I ignore the vector sign doesn't just give me a feeling of the problem, but if I just ignore the vector sign, so T2 R2 should be equals to what? So hang on, this is I into A divided by R1 it will be. Okay. T2 R2 should be, or T2 should be equals to, see, I2 into alpha 2 can be written as A divided by R2. So bring it on this side, you're gonna get T2 is I2 into A by R2 square, I2 into A by R2 square by R2 square. What's your T1? Just ignore this R1 from here, ignore this K cap from here, you can get T1 minus T2, T1 minus T2 is your I1 A by R1 square. R1 square. So here I can put T2 from this and place it over here and find out the value of A, and putting that A, or find the value of A or T, whatever you take. So therefore in this equation put T2 is this. So T1, hang on, let's put T1 minus T2 is I2 into A by R2 square, I2 into A divided by R2 square is equals to I1 into A by R1 square. Okay. from this, you just place it over here, t1, you will get the acceleration. So t1 is equals to what? Just bring it on this side. You can take common a, and you're gonna get I2 by R2 square, I1 by I1 by R1 square plus I2 by R2 square. Done. This is your T1. Just put this T1 on this equation. So mg minus T1 is ma. mg minus T1, that is a into I1 by R1 square plus I2 by R2 square. mg minus T1 is equals to m into a. On the next page, or if I just put it on the next page only, because this page it will be very much congested. On the next page, if I put mg minus T1, you said, right? T1 is what? I1 by R1 square plus I2 by R2 square. I1 by R1 square plus I2 by R2 square into A is equals to m into A. Therefore, you just see the value of acceleration you are getting from here is what? Mg, the value of acceleration you are getting is mg divided by m plus I1 by R1 square plus I2 by R2 square. That's all you're getting. This is the acceleration. Can you put the values and get the answer now? So you know the value of m, that is 2, the value of g, that is 9.8. So 2 into 9.8 divided by your small m is again 2 plus moment of inertia of the small body, so the pulley 1. This is pulley number 1, this is pulley number 1, this is pulley number 2. It has a radius r1, then it has a radius r2. Okay, tell me, if this is pulley number 2, then of course, what is the moment of inertia of pulley number 1? Moment of inertia of the pulley number 1 is 0.1 kg and radius is 5 centimeter, that is 0.05. So 1 divided by 5 centimeter means 0.05 meter square plus here I2. What is the moment of inertia of the larger pulley? In the previous problem we saw moment of inertia of the larger pulley is 0.2 kg meter square and radius is 0.1. So hang on, it should have the value 0.1, right? Moment of inertia should be 0.1. 0.2 divided by 0.1 ka square. Just do the calculation and tell me what you are getting. 0.1 20, acha, 0.05 40 20, this is 40, this is 2, 20, 40, 60 and 2, 62 well 19.6 0.316 0.316 is the answer. If I take 20, that doesn't matter, 0.316. So I'm gonna get 316 meter per second square. Okay, now I know the acceleration, right? Put the acceleration in this equation, we'll get the value of T1, and once you find T1, you can find the value of T2. Okay, you know T1 and T2, right? You can find T1 as well, you can find T2 as well. T2, they have asked us to find the value of T2. T2 is I2 into A by R2 square. Therefore, T2 is T2 I2 into A divided by R2 square. What is the moment of inertia of the second body? 0.2. What is the acceleration? 0.316 divided by, what is the radius of the second, that is 0.1. So that thing is 20. 6.32. You have 6.32 Newton. That is the tension. Good. This is your 6.32 Newton. That's your 6.32 Newton, T2. Similarly, you can find T1 from this equation. T1 from this equation you can determine. Or from this equation also you can determine. T1 is equals to what? M into G minus. T1 is equals to what? T1. See, we know that mg minus T1 is ma. Mg minus T1 is equal to ma. That implies T1 is equals to, T1 is, just bring it on this side, m into G minus a. M is 2 kg, G is 9.8, minus acceleration is 0.316. तो 9.8 minus 0.316 जो भी आ रहा है multiplied by 2, 18.968, 18.968 Newton. So T1 is equals to m into G minus a. M is 2 kg, G is 9.8 and A is 0.316, so it's done. T1 we have found out. So this question was a good question, right? After this question we can solve another problem, and this was a good question, it's understandable quite well. After this question we can solve another question, that is this one. The pulleys in figure 10 E6 are identical, each having a radius r, moment of inertia I, find the acceleration of the block capital M. They have said what's the acceleration of the block capital M, that's what they have asked. Fine, we can solve this question, let's just solve this. Come on, let's solve this. So here both the pulleys will rotate, huh? So be very very careful on that matter. Be very very careful because both the pulleys will rotate here. Both the pulleys will rotate here. Okay, first thing I can tell you is that this pulley will rotate, this pulley will rotate, so the tensions will be different. Suppose over here the tension is T1, T1, T1. This T1 is on the block, this T1 is on the pulley. Here tension is T2, T2. Of course this pulley is rotating, so tension on both the sides will be different. This pulley is also rotating, so tension on both the sides will be different. So this is T2, so this is T3. Suppose this will be T3. So this is on the block, this is on the pulley. Now you just write down the equations of motions. The acceleration will be same of all the blocks. Of all the blocks, accelerations will be same. Actually, here I need to write one more thing. Here I need to write down one more thing, that alpha, the acceleration A is equals to alpha into R1, that is alpha 2 into R2. There is one more thing, acceleration. I must mention that acceleration A is equals to alpha 1 R1, alpha 1, R1, that is actually equals to alpha 2, R2. Because both have same acceleration, right? So for this plate it will be alpha 1 R1, for this plate it will be alpha 2 R2. Good. You know this. Now let's solve this question. The pulleys in figure these are identical, each having radius r, moment of inertia I. Find the acceleration of the block of mass capital M. Find the acceleration of the block of mass capital M. What is the acceleration of the block of mass capital M? So yes, we have just drawn it here, and let's just solve this equation now. We know the equations of motion mg minus t1 should be equals to capital M into acceleration A. For this block, okay, for this pulley, okay, for this block it's mg minus t3. Okay, this one is going up, this one is coming down, this one is going up, so t3 is bigger. t3 minus mg is equals to m into a, because this one is larger, right? Capital M is greater than small m, so this one come down, this one will go up. That means of course mg this is small mg, this is capital MG. This one is going down, this one is going up. So T3 is greater or MG is greater? Of course T3 is greater, so T3 minus MG is MA. This one is coming down, so of course MG is greater or T1 is greater. MG is greater, so MG minus T1 is MA. Now this pulley must rotate then along this direction. This pulley must rotate along this direction then. This pulley must also rotate along this direction then. The rotation should happen along the anti-clockwise direction. So net tension should be perpendicular to the plane of the page and towards the reader. Perpendicular to the plane of the page and towards the viewer should be the net tension. So tell me, if this is the net tension, then what can you do? For this, it's I'm just only concerning with the magnitude. Which tension should win? Out of these two, which tension should win? T1 is greater or T2? It's rotating along this direction, so T1 is greater in magnitudes. Here. T1 is greater in magnitude. Right? It's coming along this direction. Na? You see in every problem, which is greater in magnitude. Here, as for example, it's rotating along the T1 is greater in magnitude, so T1 minus T2 into R. T1 minus T2 into R. Here, which one is there is only one tension is this, so T2 into R equals to this. So let me tell you this. You know that this T1 is greater in magnitude, so T1 minus T2 T1 minus T2 into R. Which one is greater? So this is your R cross F. So it's in the upward direction, it's outward direction. This is R cross F. R cross F is the downward direction. So of course it's rotating in this direction, so upward direction torque will survive. So therefore T1 should be greater than T2. T1 should be greater than T2. T1 should be greater than T2. I know that T1 is greater than T2 and this one is rotating along the T2 is greater than T3. T2 is greater than T3. Good. So T1 minus T2 into R is equals to what? Moment of inertia of this one, I. They are identical pulleys, so has the same moment of inertia, same radius, so I into alpha. I into alpha. So from here I can say alpha can be written as I into acceleration A divided by R. Yes. So T1 minus T2 can be written as a by ia by r square. Similarly, what can you tell about this rotation? Which one is greater? T2 minus T3. Which one is greater out of this two? T2 is greater, so T2 minus T3 into radius of this pulley, that is r, should be equals to moment of inertia I into alpha, I into a divided by r square. I into a divided, I into alpha, that is I into a by r. I into a divided by r. That means T2 minus T3, T2 minus T3 is equals to I a divided by r square. Now what can you tell me from this two equations? Can you eliminate T2 from these two equations? Just add these two equations, you can eliminate this, I think. Just add these two equations. This is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4. Add 3 and 4 and tell me what you're getting. 3 plus 4. What will you get if you add equation 3 and 4? So T1 minus T2 plus T2 minus T3. So T2 T2 cancels out, T1 minus T3. T1 minus T3 will give you IA by r square, IA by r square. So 2 IA divided by r square. That's our equation number 5. Right. Now you see in equation 1 and 2 you have both T1 and T3. You have both T1 and T3. So what they have asked you to find out? Find the acceleration of the block, right? Okay. Find T3 from here in terms of T1. Just wait. I have got this right. So find T3 from here in terms of T1. So T3 is equals to T1 minus 2IA by r square. T1 minus 2IA divided by r square. That's all. So if T3 is known, now put that T3 over here in equation 2. Therefore, equation 2 says T3 minus mg is ma. T3 minus mg is equals to ma. So therefore, put T3 as T1 minus 2IA divided by r square minus mg is equals to ma. From here you find out the value of T1. T1 equals to what then? ma plus mg. ma plus mg plus 2IA divided by r square. That's your T1. You found out T1. Just put the values of T1 in equation 1. Now you know equation 1 says mg minus T1 is ma. mg minus T1 is equal to ma. Just put the value of T1 from here to here. You're going to get mg minus ma plus small mg plus 2I a divided by r square is equal to m into a. From here you can get the value of the acceleration, which is actually equal to, if you just bring it on this side and just mg divided by what you're getting. If you just bring it on this side, so 2ma, right? So 2 into small m. Oh, this is capital M actually, I'm sorry. This has to be capital M because that's equation 1. In equation 1 you must have capital M here. Yeah. Capital M, so this is capital M. So if you just bring it on this side, capital M plus This is your mg, right? There's no ma. No. So small m g minus capital M minus small m into g minus small m into g, the net force divided by m. Okay, capital M minus small m into g. Okay, find all the a values here. So you're gonna get capital M plus small m plus 2i by capital M plus small m plus 2 into I divided by r square. They have a said radius of all the pulleys are r. So it's fine to. We should put r here because they said always the radius is r. Don't you think we should put r? R square, r square, r square, r square. This should be r square, this should be r square. Done. This question is done. So I think we are in a good state. Fine. You just have to understand that for rotation, which one is like which direction the pulley will rotate. So for that direction, the tension will be greater. So T1 minus T2 into R should be equals to I into alpha. That is I into A by R. Okay. Alpha for both the pulleys must be same. So A should be equals to R into alpha for rolling without slipping. This expression has to be satisfied. Okay, done. That's a good one, right? This question was a good question. So I will end the class over here only because it's already been 10:54. We have a class at 11 a.m. in the morning. So seeing you all at master class. And if you have any question, any doubts, you can definitely ask. And I'm just uploading this PDF on the Telegram channel. Okay. So thank you very much. And we'll see you on the next class.